Okay, hello, students. This is Mr. Ng. I'm here to just discuss some of the harder parts of the assignment on waves. Right, this for year 4 students only. All right. So, this figure 1.2 shows the displacement position graph of the wave. All right, displacement position is the same as displacement distance graph. All right. So this is actually this distance. Right. So it's a transverse wave with frequency 400 hertz. All right, and a speed of 320. All right. So we can have a look at the fact that these two are the important parameters given in the question, right? Mark the x-axis with the values of position measured in meters, right? So we already know that this is a distance scale, right? Distance in meters, right? So in a displacement distance graph, all right, the x-axis can only give us lambda. So in other words, I'm trying to find lambda. Right, how to find lambda? Generally, lambda is found from displacement distance graph, which clearly we can't get it from because that's what the question is asking for in the first place. Either that or we find it from b equal f lambda, which it so happened that we already underlined the important part. So it's 320 equals to 400 lambda. So lambda is 0.80 meters, right? So you know that one wavelength, which is here, 0.80 meters. Normally we are nice and we'll just put one more here, right? Some people will just even, put these points in nicely, okay? All right, so that's how to answer part 1. Okay, describe the motion of B for one complete cycle starting from time t equals 0. Okay, for this question, I actually apologize. There's something missing in the question, right? The question should have told you how the wave moves, right? So just take note of this, right? The wave should be moving. They should tell you the wave moves, right? It's important for this part of the question because if the wave moves right, then later on the wave will look something like that, okay? So I'll try and change the color of my pen. Okay, if the wave move right, let's say it's the red one, right? So if wave move right, looks something like that later on. I just shift the wave slightly to the right. Then you can see B moves up, correct? Okay, because remember that this is a transverse wave, which means that if the wave moves right, then B can only move up or down because the particle only vibrates 90 degrees with respect to the motion of the wave, right? So B can only move up and down, so B must sit on the waves, right? So originally B was here because the wave was the black one. Now the wave become the red one, B is now here, right? So B moves up, right? Therefore, that's why I say that the wave moving right is actually important, okay? If you look at, for example, the wave move left, right? So for example, instead of this black line, we have the blue line over here, right? This was what happens when the wave move left, right? When the wave move left, you realize that actually B goes down. Can you see that? Right, the wave move left, right? The particle can only move 90 degrees to the motion again. So B is still trapped on the red line, right? But B must sit on the wave, so B actually moves down first. All right, so when you answer this question on part 2, right, actually the standard answer given to you was assuming that the wave moves right, and therefore B first moves up to its maximum position, maximum amplitude, all right, and then he moves back down to his equilibrium position, then it goes back down all the way to negative amplitude, then it comes back here towards equilibrium position, right? That's how B moves, assuming it moves to the right. Okay, so we'll take this assumption for the whole question, all right? Because if move to the left, the answer will be opposite. B will go down first before going up, all right, and so on and so forth. Okay, can? All right, so again, we'll move on to part 3. Again, I apologize, part 3 actually depends quite heavily on the fact that we should have had this in the question. All right, so just take note that for the whole question we'll take it as the wave move right. So for the wave move right, firstly I want to find what happens to the particle A in terms of displacement time graph, right? So in displacement time graph, right, to make your life simple, right, I just tell you that there are only 4 possibilities. The positive sign, which period is here, the negative sign, period is here, the positive cosine, all right, and the negative cosine graph, right? In case you don't know how to draw, okay, I draw for you, all right? Okay, so these are only 4 possibilities for displacement time graphs. Okay, so whenever I ask you to draw displacement time graph, you just remember it's either positive sign, negative sign, all right? A, all right, let me try to get my pen. What happened to my pen? Right, it's either A, B, C, or D. Right, if I look at A, actually I don't need to care too much because A starts at the amplitude, and the amplitude I think is given as 0.3. Yeah, at t equals 0, displacement of A is 0.3 meters, right? So we have to assume that in this graph, this is actually 0.3, right? So this dotted line here is 0.3, okay, 0.3. And you see that A at time equals 0 is actually already at its maximum position, right? So at time t equals 0, which is basically this point over here, A is at its maximum position, which is 0.3. So the only graph that is possible is C. So I straight away know how to draw A that looks like that already. Okay, but this is one period, so I'll try and draw another one. Alright, so there's 2 periods. Okay, so this is A. Alright, and then later on at the bottom they ask you to sketch B. Now B is slightly more complex because it depends on the direction of motion of the wave. Alright, so again we'll take it that B moves to the right. Okay, sorry, the wave moves to the right, and therefore the next instant B moves up. Right, so B at time t equals 0 starts from rest position. Right, so from this I already know it's either A or B. Right, because only A and B start from rest. Can you see that? These are all displacement. They are all displacement time graphs. Right, so only A and B starts from rest. The question is, at the next time instant, does the particle go up or go down? Right, so in this context, for the wave moving right, for this case over here, you can see that it's the red graph, right? So B moves up first. Can you see that? Originally B was here, then B became here. Alright, so B moved up first, and therefore the answer must be A, right? So straight away, actually, I know B starts from here. Alright, if you are very worried about drawing a proper graph, alright, so I always advise students to split into 4 parts so that they are good at drawing, right? The graph. So some people have problems drawing the graph, so I'll always split into 4 parts so that you can easier to draw. Okay, so I know the answer is this one already, because if I move right, that means B moves up after being at equilibrium, right? So as B starts here, then it moves up, right? From the graph earlier I saw, right? So B starts here, and then moves up, right, to this point, because it's the red line that I'm interested in. So I can already draw the graph to look something like that. Okay, of course, I want to draw another cycle because remember, we always draw 2 wavelengths, right? So if you are afraid, you can draw the center line to help you like that, right? Then the quarter line like that. Okay, then it's easy to draw. Okay, so I know some of you struggle with this, so hopefully this helps you. Alright, and if this is T, right, this would be 2T, right? Can you calculate a period? I think you can. Right, what is the period? Period is just 1 over 400, right? Because you have given frequency here, right? So the period is 1 over 400, right? I'll press calculator. If I'm not mistaken, okay, I don't have a calculator at this point, but if I'm not mistaken, it's something like that, right? So I will at this point mark out this value, and at this point mark 0.0050. Right.